Okay, let's get started. So I'm going to do a quick video here on how to use the customized post-processor for the Torchmate 4400 and 4800 machines using Fusion's CAM software. So in order to get started, I'm just going to draw a quick sketch on any plane. I'll choose the top for now and just draw a part. You can follow along with this or you can draw whatever part you want. But I'm just going to do a center rectangle. Let's make it a 3 by 2 with a circle in the center at about 1 inch. Perfect. So once I've done my 2D sketch, I can finish the sketch and extrude it to the distance of, or the thickness of my material, which in this case is 0.125 or an 1/8 inch. Once I have my material extruded and my part drawn up, I can change from the Design tab down to the Manufacturing tab. And this is where I'll set up my CAM toolpaths. So to get started, I'll move my way into Setup. I'm going to leave machine blank. There's no defaults in Fusion for the machine that we're using today, but I will tell it that our operation type is cutting. Cutting covers laser cutters, plasma cutters, and water jets. So obviously our plasma cutter will fit within that scope. Our WCS system here, our work coordinate system, we want this to be at the bottom left corner of our material. So that's going to be this stock point right here. And as long as our X and Y coordinates look like they're in the right direction, which they do, we can continue. Double checking our model has our body selected here. We can move into our stock options. Now, there's a lot of things that we can do here in our stock options. We can choose how big or how small our stock is. But some of the things that are extremely important that we want to look out for is we want to make sure our stock is not too close to our part. Otherwise, when our plasma cutter kicks on, it will actually burn into it. So we're going to leave a stock side offset on the side and the top at 0.06 inches. And we'll select OK. So one thing I forgot to do is I need to actually change my units here, my active units, from millimeters to inches. That's very important. There we go. And I'm going to go right click on Setup and let's go back into that tab. Under the Post Process tab here, this is where I would give my program a name or a number. So I'm just going to name this a test cut. And I can add a program comment if I want, just a description to what this program actually will be doing, but we'll leave that alone for right now. So once I have a setup done on Fusion, I can actually move ahead and go to my 2D profile. So I'm going to start cutting out my toolpaths. Up at the top here, it has to select your tool. Now, you will not have any tools set up. I do have one that I've custom made, and we'll go over that in just a second, but Fusion does not have any default plasma cutter tools that'll work for us. So we will have to make a custom one. In order to do that, you just click this plus sign right here, and it will open up into a menu that looks very similar to this, except all of this information will be empty. I added a description of mine, so I have a 60 amp mild steel for 1/8 inch to 1/4 inch material, and I added a little note that the kerf is 0.050. That'll be important in just a second. So if I make my way into the cutter tab, this is where I will start designing my cutter. I'm going to tell Fusion that I'm using a plasma cutter and that I'm going to be working in the inches unit. And then it's going to ask me the question of what my kerf width of my plasma cutter will be. Now this kerf width is going to change based on your amperage and your material size. different material size using different amperages will have different kerf widths. What I recommend is if you take a look at this chart right here. This chart is in the back of your packets. And we make our way down to the 40 amp section. It gives us a list of mild steel material thicknesses. So from 22 gauge all the way up to 1/4 inch material, it gives us a bunch of settings. Now 1/8 inch fits within that range, but it doesn't give us a direct line about 1/8 inch material. So we can get a pretty close idea by looking at our 10 gauge steel here. And it'll give me some pretty good ideas of what speeds I want to be cutting at, but 10 gauge is a slight bit thicker than our 0.125 1/8 inch material. So I'll probably have to slow down the setting right here just a little bit to get a clean cut. If we make our way down, it will give us a kerf width. So at 40 amps, cutting 10 gauge material, our kerf width is 0.05 inches. If we make our way down even further, we have the 60 amp section, which does give us a direct 1/8 inch setting in our mild steel section. If I work all the way down the chart here, we'll see our kerf for 1/8 inch material using a 60 amp shield and consumable is 0.05 inches. And that's the same for 3/16 and 1/4 inch material as well. That's why in my Fusion file, I have the kerf width set to 0.05. And if you take a look back at what I named this is for 60 amp mild steel 1/8 inch to 1/4 inch. And the kerf is marked as such. So you'll have to make a custom tool for all the materials that you're using, at least the ranges of materials that you'll be using. Now, the nozzle clearance diameter for all the parts on our machines are going to be 0.998. You can round that up to 1. It's not super important, but that's just the widest point of the shield cap on our plasma cutter. We can skip over the holder settings as this plasma cutter does not have a designated holder. But this is where we can move into cutting data. Now, our machine uses feeds and not quality. And this is where we would set our cutting feed rate. Now, I set this to 190 inches per minute because from my testing, that is the cleanest cut that our machine gets on 1/8 inch material. And that's the most common material I use this type of tool that I have set up in Fusion for. If you are cutting other material, maybe you're cutting 1/4 inch, you might want to adjust this default feed rate setting to be a little bit closer to the 1/4 inch settings, which if we look back at our chart, for 1/4 inch, they recommend in inches per minute of about 90. So your feed rate settings might be set a little bit closer to 90. Now, all this is this is the defaults that will be loaded every time you select this tool. They can be changed later without having to change the tool. So you'll notice I have mine set as a range. But if I pick something outside of this range that is not the 1/8 inch option, I will be adjusting that in my actual file before I make it a Gcode. I don't have to mess with anything here in the Postprocessor. I will just click Accept. And I'm going to select this tool that I have made. Here in my 2D profile, we can see it right here. My number 1 tool is a 0.05 plasma cutter for 60 amps. Our cutting mode is going to be through or auto. And this is where we can adjust our feeds. If we don't like the default presets, we can come here to custom and fill in whatever custom speed that we would like for our cutting feed rate, lead in, and lead out feed rate. For most of what you'll be doing, your cutting, lead in, and lead out feed rates will all match. And if we move over to geometry, this is where we select what we want to cut. So I'm going to select my body here. I want to make sure I'm doing all loops. That means that all paths within this shape are going to be accounted for. And the machine will account for kerf and make sure my part is true to size if I use the start outside option. What that's going to do is it's going to start the plasma cutter outside of my part that I have drawn here and not starting on the inside. So it will account for the kerf by using the start outside option. If I wanted to, I can also add tabs here. I can do them by distance or at points, or I can select various locations to add tabs to hold material in place. But for our test here, I'm not going to do that today. I'm going to open up our height tab. Now, we don't have to play with any of this. What we'll be doing later, this is for the z-axis mostly. So if we take a look and rotate in this axis, we'll see the different z-axes that it can send. We're not actually going to be sending any z-axis G-code. If you were working with some more advanced files, you could send custom z-axis G-code. But we're going to let the machine do this automatically by not sending it any G-code within, or not sending it any z-axis G-code. We'll move over to passes. One of the main settings we're going to change here is we're going to keep sharp corners. What that's going to do is it's going to go as 90 degrees as possible when it reaches these corners versus trying to make a rounded over corner here. It's going to lead to cleaner cuts by keeping these sharp corners. Then we can move down to linking. And this is where we can set in information for lead in and lead out. A lot of these default settings are pretty good. We don't need this to be quite as long. I recommend roughly about an 1/8 inch lead in distance and keep your lead outs at about the same. If you wanted to customize your lead outs, you just uncheck this box here and you can make some custom lead out distances, but we'll just make them match. Our pierce clearance will match the kerf of our tool. And entry positions here is where we can select where those lead in and lead outs happen. So for my circle, I can select that my lead in lead out happens right here. And I can also select that my outer one happens right up here at the top. Now this allows a little bit of customization from your end. If you leave those blank, it will automatically generate them for you. But if you have a very specific location that you would like them, you can select it yourself using the positions option. Once we select OK, it'll give us a list of our tool paths. So we can see our lead in cuts around this circle here, comes out, lifts back up, drops in here, draws around our square or our rectangle, and comes right back out. So this red dot is our starting point and that green dot is our ending point. And just for proof, I'm going to rotate our view and I'm going to click the simulate option and press play. That looks pretty good to me. I can even add the stock and watch it remove the stock that it is planning on removing. And there we go. Now if I close my simulation, I can move on to my post-processing. This is where I will give my program a name and a file name, as well as tell it where to output. And it actually wants me to select my post-processor. Now we're going to select our post-processor from the library, go to our local drive, and we will have to import it. This is a custom one that Fusion 360 does not have on its own, so you will have to have access to this Torchmate 4800 CPS file. This is where you will select that file and select Open. It gives you a couple descriptions here, so customize file to output Torchmate 44 and 4800 machines, enable property, use Z to output Z moves, all of this stuff. It tells you how to use it here in the description. If we click Select, we get a list of these settings here. So we can add sequence numbers to our code. If you are looking at Gcode, you might want to use these. I'm just going to have them turned off for now. Not a big deal. We don't need them for what we're doing today. They just add space to our drive. We want to double check that our NC extension is a .gm. That is one of the only file types that the Torchmate accepts. And in order to make it work for the Torchmate 44 and 4800 machines, we want to keep the dwell in seconds, separate words with spaces, and use coolant. We will actually turn off the use M30 option. And we will turn off the use work offset option. This use Z values option is where you would actually allow it to take the Z values from your toolpaths that you have made. Otherwise, it will just automatically use Z values from the machine. So the machine will find the top of your part and use that as its base Z values. Otherwise, it will use the Z values that you gave it. Once all of these settings are selected, we can click Post. I already had a file with the same name, so I'm going to override that. And that's done. I'm going to launch the View NC code here, and we can see the Gcode. That matches. So this is proper Gcode that will actually work in our Torchmate 44 and 4800 machines that end in a .gm file. So from here, you're all set. You can save this file onto a flash drive, bring it over to the machine, and it should be ready to go.